Hello everyone, welcome. In this video we'll discuss a new topic which is complex number, and we will start our video by giving a simple question which is x squared equal 4, and we want to get the values of x. So to get the values of x, we will say that x equal positive or negative square root of 4, so x equal positive or negative 2. And we will move to another question which is x squared equal negative 4. So to get the values of x, we will say x equal positive or negative square root of negative 4. And here we will stop because we don't know what will be the value, as we have studied until the real numbers. We don't know other sets instead of the real number. So today we will introduce a new set which is called imaginary numbers, and this will solve many problems. So imaginary numbers. What are imaginary numbers? When scientists found problems with the real number sets and found that it can solve all the problems, they introduced a new set which is called the imaginary number sets, and it is denoted by letter I. So I equals square root of negative 1, and they have derived some other relations from this basic relation to solve other problems, such as I square equal negative 1, I cubic equal negative I power 4 equal 1. And these main relations are used to solve many problems, and we will see in some examples. And now we will start with our first example, which says square root of negative 64, and we have written here in the side the most important relations which will help us in solving these different equations and problems. So we will start here. It's square root of negative 64, which is composed of negative 1 times 64, which equals square root. We have seen here that negative 1 equals I squared, equals I squared times 8 power 2, and this will equal 8I, and this will be the solution for the first problem. And we'll move to the next problem, square root of negative 144, and we see negative 1 which equals I squared, and 144 which equals 12 power 2, and the solution will be 12I. And then we will move to another section which is the complex numbers, and this is an example for complex number which is 3 plus 5i. So what are complex numbers? Complex numbers are numbers of the form of a plus bi, where a and b are real numbers. A is called real part of the number, while b is called the imaginary part of the number. And now we will move to simplification of high index imaginary numbers. So we used to use I power 2, I power 3, I power 4, but we didn't use a big index such as I power 36 and I power 6. And in this example we will have I power 36 and we will simplify it. So I power 36 equals I power 4 all power 9. So I power 4 equals 1, and 1 power 9 equal 1. And I power 6 equals I power 2 all power 3. I power 2 equal negative 1, and negative 1 all power 3 equal negative 1. And now we will move to addition and subtraction and some examples on them. I have here two examples. So if we have 8 plus 5i plus 3 plus 2i, so we will add the real parts together and the imaginary parts together. So 8 plus 3 equal 11, and 5i plus 2i equal 7i. In the other example we have here subtraction, so we will subtract the real parts and subtract the imaginary parts. So 2 minus 5 equal negative 3, and negative 5 minus 3 equal negative 8i. And now we will move to multiplication of complex numbers. So in real numbers, if we multiplied, for example, root 8 times root 5, it equals root 40. We multiplied the numbers under the roots under only one root. But if we wanted to multiply complex numbers or imaginary numbers, for example here, root negative 8 times root negative 5, we first analyze it. So it equals root negative 8 equals root 8i squared times root 5i squared. So it remains root 8, and outside is I times root 5, and there is I outside. So I times I equal I squared root 40. So it equals negative root 40. And we will have here an example for the multiplication of complex number. If we have 3 minus 4i all power 2, which equals 3 minus 4i times 3 minus 4i. So we multiply the first number by the first number, so 3 times 3 equal 9. Final number times final number, negative 4i times negative 4i equal positive 16i squared, and the middle terms, negative 4i times 3 equal negative 12i, and here's the first and the final term, 3 times negative 4i, which equals negative 12i. So we got here 9 minus 16 as I square is converted into negative 1, and we have negative 24i, and the final formula is negative 7 minus 24i. And now we will move to division and conjugates. So the conjugate of a complex number such as a plus bi is a minus bi. To get the conjugate, we reverse the sign of the imaginary number. So we here got positive bi. So in the conjugate of this complex number, it's negative bi. For example, we have here 3 plus 6i, and we want to multiply it by its conjugate. So first we get the conjugate, which is 3 minus 6i, and we will start to multiply. So the first term times the first term equal 9, final times 9 equal negative 36i squared, and the middle terms we will get positive 18i minus 18i, which will cancel each other. At the end we will get 9 plus 36, which equals 45. And here we will move to an important note, which says the multiplication of a number, any number, by its conjugate will always equal real number, and it is a very important note, and it will help us very much in our next section, which is about division, and we will see more examples. And now we will move to the final part of our video, which is the division. We have here an example, which is we want to divide 2 minus 5i by 1 minus 6i, and they have formed fraction notation. So to solve this problem, we will multiply it by 1, which is equivalent to 1 plus 6i over 1 plus 6i. And why we have, you can ask why we have chosen 1 plus 6i. We have chosen 1 plus 6i because it is the conjugate of the denominator. Whenever we want to make a division using the complex number, we will get the conjugate of the denominator. So we will multiply 2 minus 5i over 1 minus 6i times 1 plus 6i over 1 plus 6i. We will start here, and by multiplication, as we have done before, it will equals 2 plus 12i minus 5i minus 30i squared over 1 minus 36i squared, which will equal 2 plus 7i plus 30 over 1 plus 36, which will equal the end 32 plus 7i over 37, and the final is 32 over 37 plus 7 over 37i, and it will be in the final form of a complex number. Thanks for watching our video, and please wait for our next videos.